Hello everyone, welcome to Incredible Study. Today in this lecture, we know about Universal Gravitational Constant, and in previous lecture we had discussed about the Newton's law of gravitation, and in previous lecture we had discussed about some Universal Gravitational Constant about something only, and in this lecture we discussed detail. So if you haven't checked the previous lecture, then check it out, because this lecture is extremely dependent lecture. Okay, so let's move to our topic. First one, we discuss under this Universal Gravitational Constant about definition. Then after, next, unit of G, and this is also denoted by capital G, Universal Gravitational Constant. So and next we know about value of G. What is the value of G and who has discovered it, who has determined or find the value of this G. And next one, we discuss about the properties of G, and then after, application of Newton's law of gravitation. We had discussed in our previous lecture about Newton's law of gravitation, and in this lecture we know about its application. So without getting delay, let's start our video. Definition. First we know about definition. Suppose here two bodies are and having center, okay, and they are separated by distance a. Their force exists between them. Okay, let the mass of this body be m1 and this body be m2. Then to define universal gravitational constant, we have to consider. So consider here m1 is equal to m2 is equal to 1 kg. 1 kg. Let the mass of first body and mass of second body be 1 kg. Okay, and distance also. Distance be 1 meter. There are two unit masses. Unit masses means having same unit, same value. Two unit masses separated by unit distance, that is 1 meter. Now we use the formula of this gravitational force. Here we use F is equal to G m1 m2 by d square. This is our formula of gravitational force existing between two bodies. This formula, about this formula we have discussed in our previous lecture. Its derivation also we have discussed in our previous lecture. So now we put the value of this m1 m2 and d. Put the value F is equal to G 1 into 1 and 1 square. Here we get F is equal to G. Okay, so from this we can conclude that the force of gravity means universal gravitational is defined as the force or the gravitational force existing between two unit masses separated by unit distance. Okay, here we write definition of this universal gravitational constant. So we write here universal gravitational constant. Constant is defined as the force existing between two bodies of unit masses which are separated by unit distance. Separated by unit distance. So here, this is the definition of universal gravitational constant. Universal gravitational constant is defined as the force existing between two bodies of unit masses which are separated by unit distance. Here this body have mass m1, unit mass, and unit distance. They are separated by unit distance 1. And this is only the condition when gravitational force is equal to universal gravitational constant. Okay. So in this way we have completed this first topic, that is definition of G, means universal gravitational constant. Now we move to its unit. What is the unit of G? Capital G. Okay. So here we understand about the value, means unit of G, and then after we go to our next topic, that is value of G. Here we have formula, that is F is equal to G m1 m2 by d square, where m1 and m2 are the masses and g is distance between these two bodies. So here, in order to find the unit of G, we derive this. We derive here G is equal to F into d squared by m1 into m2. Here F into d squared by this m1 into m2. Now to find the unit of this capital G, we write the unit of first force. Unit of force is Newton. So we write Newton. And then since the unit of D is meter, since it is the distance, its unit is meter. And here is square, we put here is square. And in down we put the value of this unit of this masses, and the unit of masses in SI is, this is the unit in SI system. Okay. So here kg into kg, that is Newton meter square per kg square we can write. Okay, this is the unit of capital G, that is universal gravitational constant in SI system. And to know it in CGS system, we just change it into CGS system. So the unit of force in CGS system is dyne, and that of the meter is centimeter, and kg is gram. So we write here the unit of this capital G in CGS system is dyne centimeter square per gram square. This is in SI system, and this is in CGS system. Okay. So in this way we have also completed the unit, that is unit of G. This is our second topic, and we have also completed our second topic, that is unit of G, unit of universal gravitational constant. And we move to our next topic, that is value of G. Okay. Next topic is value of G, that is capital G, universal gravitational constant. Okay, this is our next topic. In this topic we know about from where, who has given the value, okay, and who has found the value of this capital G. Long after the Newton's death, the value of G was first experimentally determined by the English physicist Henry Cavendish by using the torsion balance in 1798 AD, and he gave the value that is 6.67 into 10 to the power minus 11 Newton meter square per kg square. This value is in SI system. So we write here value was first determined English physicist Henry Cavendish. Henry Cavendish in 1798. He gave this value using, he calculated the value of capital G using sensitive torsion balance. Now you ask, what is the torsion balance? It is a kind of instrument to measure the value, very small value, okay? And the value of G is, the value of this capital G in SI. He gave the value in SI, that is 6.67 into 10 to the power minus 11 Newton meter square per kg square. Newton meter square per kg square. And we can also derive this SI unit into, we can also convert this SI unit into CGS unit with CGS value. And now we are going to convert this SI value into CGS value. Here we know that G is equal to Newton meter square per kg square, and its value, that is, its value is 6.67. G is equal to 6.67 into 10 to the power minus weight. That is, G is equal to 6.67 into 10 to the power minus 11 Newton meter square per kg square. We convert this all SI unit into CGS unit by keeping its value. So we know 6.67 into 10 to the power minus 11 into 1 Newton is equal to 10 to the power 5 dyne. The value of 1 Newton is equal to 10 to the power 5 dyne. And 1 meter, here 1 meter is equal to 100 centimeter. So the square of this 100 centimeter will be 100 into 100. And this is in centimeter square. And this kg, the value of 1 kg in CGS is 1000 gram. Okay, so we write here 1000 into 1000, and its value is in gram. Now we see here this side, that is G is equal to 6.67 into 10 to the power minus 11 into 10 to the power this 4040, and here 5, 10 to the power 5, here 10 to the power 9 will be, and in now 10 to the power 6, because when we convert this into scientific notation, then we will get 10 to the power 6 in down. Now we simplify this 6.67 into 10 to the power minus 8, what is the value? 9 cm square per gram square. This is the value of this capital G in CGS system. Okay. Similarly, now under this topic we have understood about this value was determined first by the English physicist Henry Cavendish, and then after he calculated this value using the sensitive torsion balance. And we also understood about that torsion balance is a kind of instrument to measure a small value. Here value of G in SI is 6.67 into 10 to the power minus 11 Newton meter square per kg square. And similarly, we converted this SI value into CGS value, that is 6.67 into 10 to the power minus 8 dyne centimeter square per gram square. Similarly, now we move to our next topic, that is properties of G. Okay. Under the properties of G, we know about the properties of this capital G. What are the properties of Universal Gravitational Constant? There we write properties of G. Properties of G. Here, properties of G means the value of G is independent of the nature of medium between the two bodies. Okay, and it is also there are three properties of this G. The value of G is independent of the nature of the medium between the two bodies. The value of G is independent of the nature, size, and masses, means size, nature, size of the body, and it is also independent. It is not affected by temperature or pressure at all. So we here write the value of this G is independent of the nature of medium between, this is between, okay, between two bodies. And next one, the value of capital G is independent of the nature, size of bodies. And last one, the value is unaffected the value is unaffected. The value of G, capital G, is unaffected by temperature and pressure. The value of capital G is unaffected by the temperature and pressure. And these are the three properties of capital G. Means its value is independent of the nature of medium between two bodies. Suppose whether the body is in the water, air, or space, the value of G remains constant. Okay, in any medium. So its value is independent of the medium of between the two bodies. Next one, the value of capital G is independent of the nature, size of the bodies. Means the what type of body it is. Nature means nature of the body, and size means whatever the size of the body. Either it is the tiny or either it is bigger one. The value of G remains constant. Here the value of the value of capital G is unaffected by the temperature and pressure. The value of G does not change whether it is in the harsh condition, harsh temperature and pressure. Okay, the value of this G remains constant in any temperature and pressure. Now we move to our next topic, that is application of Newton's law of gravitation. And before this, we know about one very popular give reason question. Okay, let me know this. Here the question is gravitational constant is called universal constant. Why? This is very popular question under this fourth topic. Okay, gravitational constant is called universal constant. Why? Since the value of gravitational constant remains is independent in any temperature and pressure, means is independent of the nature of the medium. Let me write clearly. The value of this universal gravitational constant means capital G, okay, is independent of the nature of medium between two bodies. It is independent of the temperature, pressure, size and mass of the body. The value of capital G is independent of the nature of medium between two bodies. It is independent of the temperature, pressure, size and mass of the bodies. So let me write. So its value is same for all pair of bodies at all distance of separation. So it is called as universal constant. Here gravitational constant is called universal constant. Why? Okay, the answer of this question is the value of G is independent of the nature of the medium between two bodies. Okay, it is independent of the temperature, pressure, means its value doesn't get changed in any temperature and pressure. It is also independent of the size and masses of bodies. Okay, and its value is same for all pair of the bodies, whether the pair is small tiny particles or tiny bodies or the larger or that is huge body. Its value remains constant at all distance of separation. Whether you put, suppose this is the two bodies, whether you put these two bodies at this distance or just increase its distance, the value of G remains constant. So it is called as universal constant. Okay, and wherever you go, its value remains constant. So this is called universal constant. Okay, and similarly in next topic, that is we discuss application of Newton's law of gravitation. Okay, so our next topic is application of Newton's law of gravitation. If you haven't watched the previous lecture, then watch it. And in this lecture, we will discuss about the application of Newton's law of gravitation. Means Newton's law of gravitation is used to find the distances between two heavenly bodies. That is the distance between the Earth and Moon, the distance between Earth and Sun. It can be found using this Newton's law of gravitation. It is also used to find the masses of heavenly bodies, such as the mass of Earth, Sun, Moon, etc. And similarly, there are many applications of Newton's law of gravitation. Now we write here, that is application These are the applications of Newton's law of gravitation. That is, first one, it is used to determine the mass of heavenly bodies, such as the mass of Earth, mass of Moon, mass of Sun, etc. The masses of these heavenly bodies can be determined using the Newton's law of gravitation. Next one, it is used to calculate the distance between any two heavenly bodies, such as the distance between Earth and Moon is calculated using Newton's law of gravitation. And the distance between this Earth and the Sun is also calculated using the Newton's law of gravitation. And the third point is, it is applicable to calculate the orbital period of satellite. Such as any satellite is sent in the space, then the orbital period of such satellite is calculated using Newton's law of gravitation. And the last one is, it is used in the discovery of new planets, stars, etc. These new planets, stars, these all are discovered using this Newton's law of gravitation. Okay, these are the applications of Newton's law of gravitation.